Hello everybody, my name is Zach Zanny, and this is my review for the Unit 1 exam. And the two topics I'll be discussing that I kind of had trouble with on the exam were the differences between the types of diffusion or active transport, and then also what exactly are organic and inorganic compounds and the differences between them. So, I will begin with active transport. So, active transport is defined as a cell that transports a substance from a lower to a higher concentration area. And generally, this will always require ATP as the energy source. And so, active transport is if this is a glass of water and you have your porous membrane right here, and you want all of your solutes are in this side, and then this is not so many solutes, but you want it to go across the membrane. Generally, osmosis, it would go this way, but in active transport, it's going the opposite way. So if you have ATP, you will be able to take the molecules here from the area of low solute concentration and push it towards the other side where there's an area of higher concentration. And this kind of plays into the types of diffusions. So simple diffusion and facilitated diffusion. Simple diffusion does not require energy and can only move material in the direction of a concentration gradient. Now, this tends to only be with cells and the membranes where molecules go to one side and outside the other. So if this was our cell and this is our cell membrane, simple diffusion is almost works like as osmosis. So if this was the inside of the cell, we have all these particles in here. It just flows to the other side easily with no ATP needed. It just goes by itself. And facilitated diffusion also works with a cell membrane. So again, if this is our cell right here and this is our cell membrane, facilitated diffusion, same thing, almost as the active transport. You're going to need ATP to be able to go from the area of low concentration to the area of high concentration, although the difference is this will be helped via the protein channels inside of the cell. And so that kind of sums it up for facilitated diffusion, simple diffusion, and active transport. And now moving on to organic compounds and inorganic compounds. So what these both have in common is they're chemical compounds. They're going to be different elements made up to make one molecule, and means they're made of a combination of elements. Inorganic compounds do not usually contain carbon. So that is going to be your key way to tell if it's organic or if it's inorganic. If it's inorganic, you will not have that carbon there. But if it's an organic compound, it will contain carbon. It contains other elements to go along with the carbon to make a molecule, which will be your organic compound. And these are generally going to be found in organisms. Some examples of organic compounds is in your DNA, we have sucrose, which is C12. There's the carbon, H22O11, and methane, which is CH4. Again, we have our carbon right there. And ethanol, or alcohol, which is C2H6O. And again, you see your carbon source right there, helping you to tell that this is an organic compound. Examples of inorganic compounds is water. What kind of threw me off is water. I think, well, okay, that just seems organic, it's natural, although water is not an organic compound, is an inorganic compound, because it is just H2O. There's no carbon at all. Or in your table salts is just NaCl. Cl is chlorine, Na is sodium, and again, there's no carbon being found. Or another example is baking soda, which is NaHCO3, and although that does have carbon, it is technically not it's not an organic compound, I should say. And lastly, the last example for inorganic compounds is hydrochloric acid, which is HCl. And again, there's no carbon in this one. So really, your main key point is if there's a carbon in the beginning of it, it's going to be organic compound. If not, it's going to be an inorganic compound. Thank you.